Alright, welcome everybody. We got this class, we got two more classes, so coming to the end. Today we're going to talk about a pretty important topic in social issues of computer science, and that is CGP Grey. And, the topic, we're going to watch a video, and I'm going to pause the video so I don't get copyright striked. But the topic is automation of jobs, right? One of the biggest objections to technology over the years, over the centuries, has been the fact that technology puts people out of work, right? There was a group of people called the Luddites back in the Industrial Revolution who were worried that their jobs were going to vanish because there were all these big mechanical looms and things like that. So they'd break into factories and hit them with hammers and break them and stuff like that. And, you know, if you look at it over the years, we've had just ever-increasing automation. You know, you would used to have a maid that would come to your house or live in your house, depending on how wealthy you are, or 7, servants. Like you've ever seen Downton Abbey, right? They have a whole staff of people waiting on you. And nowadays, that's basically, we have a washing machine. You know what I mean? Like you have a dishwasher. The reason why people used to have servants was because they didn't have washing machines and dishwashers and all the vacuum cleaners and all this other stuff. You actually had to have a person hand wash everything. And so if you're a lawyer, it's much more efficient for you to do law stuff and make money and then pay somebody else to do your dishes at the same time, right? It doesn't make sense for you to do, your own dishes by hand. Nowadays, you just pick up your cup and, rinse it off and put it in the dishwasher, right? So the progress of technology has been matched, you can just almost observe it as the progress of automation, right? The first real engine in commercial use was a machine for lifting water out of mines. So basically a steam engine pump that would pump water up out of a mine, and then you don't need humans sitting there manning the pumps, you just have an engine doing it, right? And then we replaced horses with cars and trains and airplanes and things like that. Sailboats used to require tons of sailors to pull on the lines and lift the sails and stuff like that. Those of you that went to my sea shanty talk know what I'm talking about. There's quite a lot of ropes on a sailing vessel. And nowadays you can actually solo, an Atlantic crossing if you're daring. You can get automated rope lines to put your sails up and down. We also don't use sails. We use, propellers that are powered by, various types of engines. Nuclear, aircraft carriers and things like that are powered by, uranium or whatever. But over and over, we've seen through the years technology sort of eliminating these sort of menial labor jobs, right? Where, Tesla comes in and says we're going to automate away most of the hand, labor on building a car. And then, it turns out to be a big problem. And then apparently Tesla had to kind of go back on that promise to have a fully, I don't know if it was a promise, but apparently it was just hard. And that's probably not a surprise to anybody that knows anything because manufacturing is hard. It's ridiculously difficult. And so, a lot of people were like, go humans, because they tried, using robots for everything, and apparently what they found was that hand inserting the brake lights and things like that, humans were able to do, and it was just too hard for robots to do it. From what I heard, I don't know if it's true or not. And so they had to not quite automate everything, but by and large, the gigafactories or whatever they're called are very, very automated. The future in WALL-E is coming true. That's why their cars have all these manufacturing issues, tons of panel gaps, using testing chips in finished vehicles. Yeah, I don't know how they're handling that chip shortage, right? Because that's something very new, right? Which is we just don't have enough chips. And we can probably talk about the chip manufacturing process too and the chip shortage after we do this. So, CGP Grey, as sort of a thesis statement here, if I can summarize this argument, is that while automation has been sort of eating away at the low-end jobs for really centuries, his argument is that once we get AI, once we get, automation of the brain, then, huge swathes of our population will become unemployed, right? Like, why go to a lawyer if you can have an AI, write a contract for you or something like that, right? Why pay a musician to compose music when you can have an AI compose music for you? And so I'm going to pause the video now. For those of you at home, I'm going to put the link into the Discord here. And I'm going to pin that to the lecture room. And so when you get to this point in the recording, just pause it, watch the video, and then come on to the chat area and give me your response. Give me your unvarnished first take. Do you agree with him? Do you disagree with him? Did he use any fallacies in his in the video? Things like that. Okay, and so that's something to watch out for, because I do think he actually uses several fallacies. Most common of which you might call like the inevitability fallacy, right? It's inevitable this will happen, and that's something that is a rhetorical trick, right? That has been used for a long time. Like Karl Marx said, the revolution is inevitable, right? It's just scientific fact that in the future X, and that's just like, no, like it's really hard to predict the future. It's super hard, especially when it comes to people. And so keep an eye out for that, but also pay attention to see if he does any other fallacies, and maybe I'll put a quiz question up on that topic for Monday. Okay, so I'm going to pause the video now. Those of you at home, watch it, come back, give me your hot take on it. All right, that was Humans Need Not Apply by CGP Grey. So, a couple big takes from that. Go ahead and give your reaction to it now on chat. Crazy it's from 2014. Yeah, it's true. Like, if you look at the progress that's been made on autonomous vehicles in the last 8 years, like, it's pretty significant. Tesla's selling things that are kind of autonomous. Kind of. A pretty big step up from like 2001. In 2001, I had some friends that were working on autonomous vehicles when I was in the department, computer science department. And it was a very primitive field back then. Like the DARPA Grand Challenge was to have autonomous jeeps basically navigate through the desert because they didn't want to run over people. And so they marked off a course through the desert, and you had to program a Range Rover or something to go drive through a desert course. And year after year, just none of the vehicles completed. They all went off, right? And now we're in a situation where it's all right. It's still not. They must know the future. Yeah, and it's already here. Is it? I mean, sort of. Right? Like, another day, another crash. Customer Tesla immediately crashes into dealership sign. Here is a Tesla driving into a plane. They did the summon car feature, and the car drove right into this plane and kept driving. It didn't even notice the fact that it had run into a plane and just kept pushing this plane, causing, I don't know, probably millions of dollars. I don't know how much. Right? And so, when I said that CGP Grey overstates the case, it's here already. Well, kind of. Kind of. Robots are becoming the new human. What's the point towards working a career that probably won't exist in the future? How do you know it won't exist in the future? What career are you talking about, Emily? It's really hard to predict the future. It really is. How the economy value things will cost, since labor will be close to zero, the money, So it's if you could lower the labor cost on something to zero, it becomes cheaper to make, and then it's more affordable, and then more people can buy it. And so there's no simple answer to this kind of stuff, right? And if everyone is unemployed, then what do you think I know what the answer is, but what do you think CGP Grey was referring to when he said we need to talk about what will happen when we have 25% of the population, 45% of the population unemployable due to no fault of their own. And, you know, we can probably talk about if through no fault of their own is accurate. What do you think he's trying to get at? What do you think he's proposing? Does anyone know? There have been some experiments on this in I think Stockton, UBI, yeah, universal basic income is what I'm pretty sure CGP Grey is pushing for, like having universal basic income. Basically, everybody gets money, and if you want to work, you can have more money, but basically everybody gets money. And this is a very popular idea among technocrats, you might call them. We sort of imagine this Wall-E future where we have all these people sitting in scooters going around, and robots do all this stuff, and you just get some free meat smoothies, every day, that kind of stuff. Stream is paused. Well, you're not really missing anything here. Just me talking over a grass field. Positive or negative effects depending on what the makers of the bots do. I want to play video games all day long. Yeah, it sounds great, right? Have you ever had a summer though when you just sit at home all day and just play video games all day? It gets kind of depressing. It's kind of depressing. Will that gear economy towards communism rather than capitalism? Yeah, I mean that's probably their leaning. Yeah, is my guess. There's I think Marxists and socialists would use UBI as sort of a goal, right? So you just get machines to do all the work, and then humans live a life of luxury. Can we all be programmed to play video games? Problem with AI is that it's not perfect. It has faults that can and will do jobs better than humans. Yeah. So for example, I talked to UC San Francisco. They're one of the top medical schools in the world, medical school, pharmacy school, that kind of stuff. And I talked to one of their top researchers, and he said all this talk about Watson and stuff like that, and he just started listing off reasons, and I wish I'd written them down, but he just started listing reason after reason why Watson is important, but at the same time the threat to doctors is vastly overstated, right? Because diabetes, right? One of the signs of diabetes is your urine changes color, right? Do you know what also makes your urine change color? Drinking more water or drinking less water, right? And if you just punch in my urine changes color, then the AI is oh, you might have diabetes, and do you drink a lot of water? Another symptom is you're drinking a lot more water, and you punch that in. You I don't know, eat a lot of sweet, and so basically people in Fresno summers where it's hot outside and you're shotgunning water if you do any active activity, and your urine changes colors because you're dehydrated from cutting weeds out in the 110 degree, weather, then Watson says, you've got diabetes, and you're like, what? I do? And then maybe you don't even go into a doctor at all, and the doctor's like, no, you're stupid. You just I have diabetes now, and you just start I don't know, just not eating sugar anymore, which maybe is a good thing, I don't know. But there's a real risk that if you don't have somebody with just common sense sitting there going yeah, no, that's just called normal Fresno weather, yeah. And the irony was that we were working on a project with him that was similar to Watson. So my students and I did an app for the UC San Francisco people that would use their research. We didn't do any of the medical stuff. I'm a computer science guy. I don't know anything about lung cancer and stuff like that, but we can write an app, right? And so what we did was wrote an app for them using their research that you punch in these different factors. I work in agriculture, And then it tells you what percent chance that if you have nodes in your lungs, it's lung cancer versus coccidiomycosis, which is known as valley fever. So valley fever is basically a spore that gets kicked up by dust, and it's all over the place in the ground in the Central Valley. And you walk by a construction site, and they're kicking dust up into the sky, and you breathe it in. Now you have spores in your lungs, right? And for most people who live in Fresno, they've been exposed and are immune to it now. But in a small fraction of people, they die, right? And so we wrote an app that would sort of do a diagnosis of it. Not a diagnosis. I don't want to say a diagnosis. It was just sort of a statistical engine. And it was supposed to be used by doctors, right? Because doing a biopsy, like cutting into people's lungs, has risks itself, right? And so you want to look at the stats and figure out, is this likely to be lung cancer? Is this likely to be coccidiomycosis, valley fever? And but it was not a tool to be used by people. It was a tool to be used by doctors who, using the latest research, could use it to determine the relative risk of doing different options. So another thing, this is 8 years ago, right? Have we had more automation or less since then? That's funny. I don't know. More, I guess. Yeah. I mean, if you look at how chips are made, which I can go over in about 10 minutes, they're highly automated, You look at airports, and, new airports are built with all these highly automated baggage carrying systems, and the unemployment rate right now is pretty close to zero, right? So I don't know. It's been 8 years, CGP Grey. Maybe someday, but it's already here. It's a reality. Well, is it? I still go to Starbucks and have them make my coffee by hand, And coffee making machines have been around for a long time, right? At one of the places I used to work, you would just go up to it and put in $1 and be like, make me a French vanilla latte. You just hit a button and the thing goes, these things have been around since at least the 80s, right? I don't know. I think he's sort of underestimating that people like things kind of made by hand. I don't know. Some value in that, especially when you can see it being made. Home coffee machines, yeah. I mean, geez, you can have your own coffee maker since, I don't know, when was the first coffee maker made? The 30s or 40s, Okay, 1865. Fair enough. It's been around for a long time, and we still like going to a cafe. I like going to the Mug. If you guys go to the Mug, it's a coffee shop in North Fresno. I like the owner a lot. Going there, talking to the owner, talking to the people. The owner's wife baked these pastries, and they make, they have all sorts of interesting ideas for flavors of coffee and stuff like that. And no, I mean, I could have a coffee machine wake me up every morning with the smell of freshly brewed coffee. That's the way my grandparents did it. I am somehow less automated than my grandparents when it comes to coffee, because I like getting handmade coffee. I spend a lot of money on coffee. Maybe I should get a coffee maker, because you can program them, right? You can program them so that at 5 o'clock in the morning they turn on, and then it fills the whole house with the smell of coffee. It's definitely an idea. Yeah. You just put a timer on it essentially, and that's been around since forever as well. Okay, so let's talk about the so the point is, we've had increasing automation, and our unemployment rate's essentially zero right now. In part, due to the low interest rates and things like that, but it's counterexample, to CGP Grey is well, it's been 8 years, So It's inevitable. It must happen. It's already here. Yeah, it drives me crazy. I don't know. So speaking of automation, you guys ever wonder what the comments are saying on it? Yeah, that's a good question. Pull it up. Alright, that's pretty funny. You might think technology can't replace your job. I'd be pretty horrified if technology started replacing unemployed people's jobs. Interestingly enough, my job primarily consists of me writing code to do my job for me. I'm quite literally writing a replacement to me to take over my job and make me redundant. Comedians, they can't replace me. Robot weed eater. Comedian, no. They just broke every student currently studying for their dream job's dreams. Yeah, I would not worry that much. You know, like 20 years ago, they were saying that robots would replace pharmacists, right? Because they're machines that will dispense pills into, the pill containers, right? Still a pharmacist, still a pharm techs. In fact, probably more of them now than there were then by quite a large margin, 20 years ago. So yeah, automating those things didn't seem to make the pharmacy side of things go away. The pharmacists can now look at the drugs and see if you have a problem. Now they're saying, well, robots can know about drug-drug interactions. Well, okay. So do pharmacists. It's literally their job. And moreover, they know which ones are important and which ones are not important. And if a doctor enters the wrong drug into the electronic ordering system, how the hell is the AI going to know? Like a human can look and be like, yeah, that seems like it's a mistake to me. But to a certain extent, yeah, that does exist. Like my wife literally writes rules into the electronic ordering system that says if you're ordering this drug, here's the minimum dosage, here's the maximum dosage. And the minimum and maximum dosages are based on things like your body weight and kidney function and things like that. And so it'll compute like a therapeutic range that's okay. And if a doctor tries ordering something that's like outside of that range, it goes, bloop, like you're wrong, And then the doctor can like call up the pharmacy, like, no, I really want to give a higher dose. Yeah, but that's too high a dose. Yeah, but this guy is, homeless. He is not going to take his second dose. I want to get a lot of, antibiotics in his system now because I know he's not going to take it. So when we discharge him, it'll keep working for another 2 days. Sure, it'll cost him a little bit of kidney function over, 50 years, but he'll die, from this infection because he's leaving right now and there's nothing we can do to stop him. It's things like that is why you need humans, The AI and humans work together, right, to do this kind of stuff. So I don't think it's as doom and gloom as he makes it out to be. Maybe once we get general intelligence, Once we get AI that can think like humans and make new AI, then they make better AI, and then those better AI make better AI, and you end up with the singularity, right? And who knows what the hell will happen then. Okay, who wants to do all that math by hand? Yeah. Okay, so let's talk about chip making, just because this is kind of an interesting example of automation, okay? Because we have a chip shortage right now, right? And so here's China, here's Taiwan, here is the place where a company called TSMC is based out of, and my face keeps vanishing. Let's see here. And so TSMC is currently the only company in the world that makes the highest end, do a projector, there we go, the highest end chips in the world. And that has pretty important geopolitical implications, one of the reasons why all these countries are like, worried about China invading Taiwan potentially is because of this company right here, right? And Taiwan Semiconductor Manufacturing Corporation. And 10 years ago, there were probably 10 companies that could make the highest grade chips. Now there's like one, maybe two if you count Intel, but Intel kind of fell to second place. and Intel might actually start using TSMC to do their fabbing. So it's, all this tech stuff has huge geopolitical implications as well, because if Taiwan got destroyed, then, how are you going to make a car? Wait, what? What does a car have to do with a chip? Well, cars today's are floating computers, right? Like they're computers that float on 4 different tires and move around and just happen to have an engine, right? A car, it has, I don't know how many chips in it, like a lot. It's a CPU on wheels. Okay, that's what a car is, right? And or a CGP Grey says an auto. Yeah, we call them autos already. I don't know what you're getting at, but a CPU on wheels, and then for an autonomous vehicle, you just add a little, LiDAR spinny thing on top, and that thing scans the world, and there you go. Yeah. So, how do you make a CPU, and why is it so hard, and why is there a chip shortage? Okay, chips are in a lot of things. Yeah, like vaccines. Wait, no. No, it always drives it drives me crazy when people say, they're putting chips in vaccines. It's like, do you know how impossible that is? For one thing, there's no power source. For another thing, chips aren't invisible ever, and they're not that small. They're not like, do you know how like big a chip is? Like, they're not that small, and you're certainly gonna see it. If somebody's injecting like little potato chip fragment looking things into your blood, like you're gonna go be like, like it's the dumbest. Like, of all the conspiracy theories, I think chips into vaccines is literally the dumbest one out of all of them. Okay, so YouTube strike. Yeah. Yeah, don't ban me, Google. All right, so here's how it works. So when you make a chip, you start off by taking silicon, right? Silicon is like, think of it as beach sand, right? You just go up and scoop up a bunch of beach sand. We don't, but you can think of it that way, right? And then you melt it, and you end up getting these like silicon ingots, which are kind of cool looking. These kinds of things, right? And then they get sliced into platters like this, and that is what chips are fabricated on. So they don't just randomly grab sand from their front lawn. Like, there is an enormous amount of quality control that goes into every step along the way. Like, it's just beach sand with lightning in it. That's all a chip is. Like, it's a little more refined than that, right? Like, to the level of like 99.99999 whatever percent. That's at every point along the way in making a chip. They're incredibly precise and incredibly quality controlled, and it is just an amazing process. If you ever go, that's probably the Intel Museum, actually. Whatever. If you ever get a chance, go to the Intel Museum. It's in the Bay Area, and they'll show you the whole process. Anyway, so you end up with one of these wafers, right? One of those shiny metal things. And what's going to happen to it is that it's going to have a bunch of chips printed on it like this, right? And the bigger the chip, obviously, the less chips you get, right? Make sense? A really small chip, you could do 1,000 of them. I don't know. A big chip, maybe you get, I don't know, 40, right? Does that make sense? So, really tiny chips are cheaper, right? Really big chips are expensive. And then there's a compounding problem with that, which is that every so often a little bit of dust in the air will shoop and land on a chip, or even worse, a copper like let's just say copper gets onto that. It's at like there's designated points inside of a fab where you can use copper. You can't even carry pennies in your pocket because it contaminates the things. And if they do that, and you've got like a wire on there, and then big piece of dust lands on it, you end up getting a short, and the chip doesn't work. Okay. And so, what do you think is more likely for dust to land on? A cheap CPU or a expensive, bigger CPU? Which one has a bigger target area? Let's say. Bigger ones, yeah. And so the failure rate is bigger for the bigger ones, right? And so not only are the cheaper ones smaller, so you can fit more of them onto a platter, but their yield rate is higher, so they're cheaper for that reason too. And that's one of the reasons why you've ever wondered, like, why a 3090 is so damn expensive. It's because, you know, these things are using colossal sized GPU chips, right? So, so how does this process work? How do you print a wire onto a chip? It seems like a really weird concept, right? And the magic that makes this happen is something called a transistor. And you might have heard, you know, this chip has 5 billion transistors on it. Well, all a transistor is like a switch. And so if I say, hey, close, then the switch closes and current flows. If I say, hey, open, then the thing opens and current doesn't flow. That's all a transistor is. Okay? You can open it and close it. It's like yelling at somebody to turn off lights or yelling at somebody to turn on lights. That's literally all a transistor is, and it can do it very quickly. And you can make these very small. And if you have a couple transistors, then you can make an AND or an or a NOT gate. And if you make an AND and or a NOT gate, you can make a bit of RAM, 1 bit of RAM, you know, a couple of those things. And if you take my discrete math class, I walk you through all the levels up. But the upshot is, can you print a transistor onto that piece of silicon? And the answer is you can. What you do is you shine light on it. What you do is actually you first take the wafer and you put what's called a photoresist on it, which is basically like film. Like before we had digital cameras, we had these things called film. And that's literally the technology that we use to make the world's most expensive chips. You put a photoresist on there, and then you shine light on it, okay? And you shine light on it through a mask. Like imagine a little slit. You shine light on it. Nowadays, we use something called extreme ultraviolet light, which allows you to make very, very fine lines and things like that. And you shine lines on it like this, and it develops the film wherever it shines. It develops the film, just like people used to do back in the 80s, right? You would take your roll of film and drop it off at the grocery store and then come back a few days later and your shots are ready to go. And so what you do is you shine laser light on it, and it's very precise, very precisely controlled. Like it's ridiculously precise because it has to be able to make lines that are on the same spot every time to like the atom level of precision, right? It's an extremely difficult thing to do. And that's one of the reasons why, you know, this is a company that makes this thing that does the laser. There's only one company in the world that can do that, and there's one company in the world that can fabricate chips down at the smallest node size. And so anyhow, long story short is you shoot lasers at this thing, and it draws wires essentially onto the chip, and then you wash it with acid. And what happens is every place that was developed, everywhere the film was developed, the wires stay, and all the rest of the photoresist gets etched away. And then you add some special chemicals to it, and you turn you dope the region into what are called N regions and P regions, and that is what essentially is a transistor. And so basically you shine light, develop it, wash it with acid, and then you dope the different regions with positive and negative. And by doing this at a very small level, you create something called a transistor, and transistors create logic gates that do all the intelligence, that do all the memory storage, all that stuff, all the way up to being able to play World of Warcraft on your computer. And it is very, very difficult to get it right. Because when we started off, like people would actually do the masks, like the little light, the little slits that you cut through, people would actually do it by hand, and then they just shrink it down and then shine light through it and do the photoresist and all that stuff. Nowadays, you're talking like this wire here is going to be like, I don't know, like 10 atoms wide, 15 atoms wide, you know, atoms, right? And if you have another wire over here, right, these are like atoms or whatever. If your thing is just off by just like a couple atoms, then they short together, right? And the thing doesn't work. And you've got billions of transistors on one chip, an extremely small size. And there's one problem, actually there's a lot of problems, but like what happens when you shine a light through a slit? Do you know? Anyone taken physics before? If you have a very narrow slit and you shine light through it, what happens to it? You don't get a narrow strip of light. Mm-mm. Watch what happens. If you shine a light through a slit, it goes out like that. You don't get a straight line. You get something that looks like this. And so you're going to be developing the film not just in the spot where you're trying to develop it, but off to the side as well. The light intensity is highest to the straight, but you get a ringing effect over this way. Okay. And so when you shine a light through two slits, then they constructively interfere with each other, and you get this pattern. So you're going to be developing things not just where you're pointed at, but off to the sides as well. And so what they do is they put a second mask behind it to block these ringing effects, but then those cause ringing, and so they have layer after layer after layer of mask, and it has to be done at a level where you're like to the atom precise, right? It's extremely difficult, and Intel has been working on this problem to move up to the next, smallest feature size that the TSMC is, and failed. They haven't been able to get their chips to work, and so as time has gone on, only one company, TSMC, has been able to keep pushing the features smaller and smaller and smaller. And when you make the features smaller and smaller and smaller, you can make these things smaller and smaller, so your yield rate goes up, your cost goes down, your speed goes up because things are closer together to each other, and power consumption oftentimes goes down. And so all the competitors go out of business because nobody wants to buy a chip from them because you can buy a cheaper chip that's faster, right? It's one of the reasons why AMD is doing so well right now compared to Intel, right? So, it's a very hard problem. One of my friends is one of the people who works for ASML, and works on this kind of stuff. It's very, very hard. And he's been to China and been to Taiwan and all these other things. And could probably build one of the systems from scratch. Like if you just gave him a room full of parts, he could assemble the entire thing in a couple of days. I asked him that, and you could tell his blood pressure just kind of went up, like the idea of having to assemble it from scratch. But these things are like the size of like a trailer, like these are incredibly expensive and high precision devices. And we're in a situation where we can't actually produce enough chips to meet the world need. So, like car manufacturers, they canceled their orders, right? They went to TSMC during the pandemic, said we don't need our orders of chips anymore. So TSMC is like, all right, fine. We'll move to the next one. And then after the economy started picking up again, they're like, hey, we want our chips. And they're like, no, you cancel them. Sorry. Like, you're going to have to wait in line. You have to go to the end of the line and wait 2 years for your chips. And so that's one of the reasons why the price of new cars and used cars has gone through the roof, because car companies can't actually source enough chips to put into the cars. Like the cars run on chips. Your car is non-functional these days without a chip in it, and like 10 chips, right? And so all of these things we talk about, they all connect together, right? The geopolitics of Taiwan, how hard it is to draw a straight line, down at the atomic level. The fact that your Honda Civic that's 10 years old is now worth more than it was, 4 years ago. All these things like tie together. Automation, labor costs, like everything in the world like connects to each other, and it takes a long time to like, can I do this? No. I know about it. I can't do it, but just knowing about things like makes the world a lot more the world starts making sense, right? When you're like, okay, this is why all these companies have been like stating they're going to protect Taiwan, right? Because if TSMC got obliterated, like just like dominoes falling all over the place, like General Motors goes out of business, right? Because they can't make any cars because all their cars come from Taiwan, right? All the chips in their cars come from Taiwan. Like the world just makes a lot more sense when you understand technology, when you understand history, also when you understand the interrelationship of things and things like that. So I wouldn't be too pessimistic about CGP Grey's predictions. If we do ever get general intelligence, then that's a wild world that we'll be living in. But until then, it's like, you know, like I said, it's been 8 years and we have more autonomous vehicles now, right? You can, you know, they do exist, but the disruption wasn't as soon and wasn't as dramatic as he made it sound. Okay. Yeah, EV light has less spread. Yeah. Yeah, it's a you want to use as narrow a wavelength as possible. And the way they make it is actually kind of cool. The way they do the laser light, it's a 10 laser. And so what they do is they have super hot droplets of 10, and they shoot molten blobs of 10 into the air, and they shoot it with 2 different lasers, and that is the light source because it gives off this giant flash of light from kind of exploding the 10. Yeah, so it drops droplets of 10, and then these lasers hit it, and it releases an intense burst of light that then goes through like a series of like 30 mirrors to direct it directly onto the silicon wafer. It's like I said, every step along the way is just incredibly complicated, and yeah, there you go. You're dropping that, you hit it. Yeah. So it's wild. It's really interesting, and according to my friend, they're hiring. So I don't know. Go apply to ASML if you want a job. They're a Dutch company, I think. All right, so that's it for today. Sorry, we ran a little bit long, but I hope you enjoyed the video on humans need not apply, even if you disagree with it, or maybe it will make you rethink your job. You know, I don't know. It's something to think about at least. All right, so that's it for today, guys. Thanks a lot. See you on Monday.